Hello, today we will learn how to solve a matrix equation. So we already learned how to multiply by scalar and how to add and subtract matrices, and now we will combine all those concepts to solve for x and y in these two matrices. So first, we will use the distributive property to multiply each matrix by 4. So you see the parentheses here. This means that the 4 multiplies both matrices, and so we will distribute the 4 and multiply each one of the matrices by that scalar. So let's first multiply the first matrix by 4. And so as you might recall, what we do is just multiply the scalar by each element, and our resulting matrix should have the same number of entries with rows of the same size and columns of the same size. And so we just multiply 4 times 2 is equal to 8, and we put it exactly in the same place as we had the 2. So if it's in the first row, first column, we are going to place the 8 in the first row, first column. Very well. Now 4 times x is just 4x. 4 times negative 1, negative 4. And 4 times 5, 20. So we successfully multiplied our first matrix by 4. Now we need to multiply our second matrix. So we will do exactly the same thing we did in the previous slide. So now 4 times negative 3, negative 12. 4 times negative 8, negative 32. 4 times 6. So sorry, I just noticed that I copied this wrong, so I will fix it. So if we go back to our equation, we see here that we had y and 1. I messed up the matrices, so okay. But the first row is all right. So our second row is 4 times y, 4y. And 4 times 1, 4. And so now, as you might recall, we were just doing the distributive property. We already did that. And so now we must add both matrices, the two that we found. So here I'm adding both of them. And so to add, as you might recall, if they are the same size, we can add them. If they are not the same size, we cannot. And in order to add them, we just take the corresponding entries and add those numbers independently. So 8 plus negative 12 is negative 4. And then here we just have 4x minus 32. And then 4y minus 4 and 24. Very well. Now that's equal to this matrix right here. So every kind of information that I'm getting is just from our regular equation, our original equation. And so we must set this matrix right here equal to the matrix that we had previously. So now we set them equal to each other, and we see that the entries that should be the same are actually the same. So negative 4 and negative 4 are equal, and 24 and 24 are equal. So since our size and our corresponding entries are equal, we know that these matrices are in fact equal to each other. And using that property, we know that this entry must be equal to 8. So we know that 4x minus 32 should be equal to 8, and that 4y minus 4 should be equal to 6. Using these properties, these equations, we can now find the value of x and the value of y. So we take our first equation and we will solve for x. So we add 32 to both sides. We get 4x is equal to 40. Divide both sides by 4. And we get that x is equal to 10. Now for y, we add 4 to both sides. 4y is equal to 10, and now we divide both sides by 4, and we get that y is equal to 2.5, or just 10 divided by 4, or 5 divided by 2. So we just solve for x and y, and that's it.